Dear customers, welcome to the video on how to successfully print with the Otter S40 DTF line. But first, let's imagine the device.
Otter provides a comprehensive DTF printing solution, covering everything from consumables to equipment, ensuring a one-stop service. Using Epson's latest i1600 print heads provides highly precise prints on your films. The built-in powder shaking system is equipped with a stirrer. The powder can be evenly spread on the transfer film. The powder-coated film is automatically transferred to the oven. The oven has 5 heating tubes, so that the powder can be melted more quickly and evenly. There are 3 built-in fans that accelerate the printed film cooling. It has an automatic winding system, and the printed film can be taken up on the reel automatically. We also offer an Otter heat press for transferring your designs onto items. Your ideas come to life in just 15 seconds. Our system comes with a 1-year limited warranty and offers multilingual after-sales support, including on-site service for Mexico, the United States, and South America. The print platform supports the most popular film sizes on the market. Equipped with 2 Epson i1600 print heads for more precise printing. With 3-stage heating in the front, middle, and rear, accelerates the ink drying. The adsorption platform works with adjustable pinch rollers, ensuring a snug fit of the film to the platform and allowing for a smoother printing process. The built-in alarm sensor reminds you to add ink in time, minimizing damage to the printer. Equipped with a peristaltic pump, the continuous circulation of white ink prevents sedimentation and printhead clogging. The printer automatically cleans and maintains the printhead at regular intervals, ensuring optimal printing performance. The pause and emergency stop function is a safety design to stop operations immediately to prevent emergencies. This control panel can adjust the temperature, speed, and power. The purification system automatically handles smoke and oil, and without the need to replace filter cotton. With a multi-language system, automatic layout, and pre-created curves, you can efficiently get what you see is what you get results.
Let's take a look again at how and where the foil goes through the entire device. It should be clear or obvious from the previous video. But here we'll show or see a few extra things that maybe weren't seen in that video before. This means that the printer clamps the entire 100 meters, clamps the entire roll here on the holder, and learns to feed the film into the printer in such a way that over the entire 100 meters, the film deviates by a maximum of 1 to 2 millimeters left or right. But definitely not more. And definitely not to make any waves or anything like that during printing, because that would simply damage the printing itself. That means, that's the number one thing, learning how to lay the foil straight. The second thing we are counting on here is preheating. In this part, in the middle, and here, there are heating elements and they preheat the foil here in the first phase and, let's say, stabilize it in some way if it is damp. They simply put it in good shape. Then the printer prints on the foil, and then gently dries and stabilizes the white color. This means that here, as standard, a carriage with a CMYK and a white print head runs, which means that here we normally have CMYK, and then here it is covered by the white one. So, we want the moment the white starts to settle on the foil, for it to immediately become matte, stabilize, and not be too wet. Then the foil moves on, and here we have a powdering device that pours powder downwards onto the foil. It creates a thin layer down here, and then it circulates upwards here. Then the foil moves further and hits the blades, which shake off the excess powder from the foil. And then here we have a cylinder that has holes and a vacuum suction runs through it. And that cylinder holds the foil in place so that, during the start of printing, and this is the phase, the entire system works for us, because the printer itself would not be able to push the weight of the powder that is already here further into the system. This means that we have a vacuum suction going on here. This vacuum suction sends the foil further through the oven. The furnace, as seen in the previous video, has heating elements here. The heating elements simply heat it up and dissolve all the powder. And actually at this moment, on the next cylinder, or on the output here at the back, we should already have completely baked powder on the foil. And everything that's actually down here is just used to cool the powder and the foil. And it was possible to wind the foil onto a winding device. From there we have fans here. There are 3 fans. The foil goes through another cylinder or roll in front of those fans. It passes through another holder, and then here comes the howling device. So, actually, at this point, everything should be dissolved. It's getting cold here, and here the winder or the roll is used to actually. When we get the foil all the way here, we turn off the vacuum suction that is in this place. And the feeder or the moving mechanism, which is connected to the rest of the printer, moves it further down in 20 centimeters intervals, and the automatic winding system is simply sliding. That means, whenever we move something extra here, he just automatically rolls it up for us. Just such a gentle force. This means that the moment the foil reaches this stage, the vacuum suction is turned off. And in this state, the printer can print for hours until we finish printing. Then, when the printing is finished, that means the printer will finish printing for us here. We leave about 40 to 50 centimeters of extra empty foil there. We'll let it slowly go through the process of powdering and shaking. And here at this moment, we'll put a weight on the foil. And let's say we wait another 4 to 5 minutes until everything is cooked through. And actually, as a result, the press is such, let's say, ended a long time ago. We're just finishing it up here, and then we'll just drag it out like that. We'll turn off the winding system and just stretch it out until it cools down. And what is DTF printing as such? In the DTF process of the entire one print run. Even if it was only made up of 2 meters, or it was composed of 4, 5, 6 hours of continuous printing. So in this case it is finished. Now let's see what is possible, whether through the printer menu, or panels on a printer, or through control software. What can be set? And how should it be set up so that everything works as it should? So what's important to us is that here we have, in the case of white ink, we have a mixing system with paddles here, which rotates at an interval and length that one sets via the printer panel here. That is, where the mixing takes place, mixing white paint at certain intervals. We ourselves at the company have a set interval of 10 minutes, and stir for a minute. This means that every 10 minutes it slowly mixes the white ink in the white ink cartridge for 1 minute. In the case of SimYK, it does not mix as such. There is no mixing going on there. This mixing only makes sense for white. Then the next thing is through the pump, which is attached here on the edge of the printer. And from here it goes into a large hopper. It goes here from the big tank, above the printhead cart, and from here, for dump trucks are filling up. And there's the printhead. That means, and it goes back to that pump here. So there is a circulation going on here. Also the circulation, it can be set more or less the way you want. We also have a 10-minute interval set. And that's circulation for 1 minute. This means that with this setting, if the printer is idle, whether printing or idle, 30 minutes, or 31 minutes. So that means that here at that time there is an interval of 31 minutes. We mixed white paint in a white container 3 times. And 3 times we had white paint circulating through the entire system, just above the dumpers. So much for the color white. Next, what kind of sensors are there? There is one sensor here in the middle that monitors us, or would report a problem if there was a problem with loading the foil, or if it did not detect the foil. By default, the sensor is turned off. I think it's not normally necessary, because there is very good visual control over the foil, and you can see how much is still there, or not. Another sensor is the proximity sensor, which is actually up here in the climb. So the sensor moves the foil in this direction, and it actually oscillates here on the cylinder, let's say 5 centimeters left and right. So that's another sensor that's responsible for when it actually sends the foil up when approaching. Or further into the baking system and so on. So that's another sensor that we have here. Of course, the control panel here monitors and regulates the movement settings, the temperature in the actual oven, and even the automatic movement here when it stops working or the vacuum suction is turned off. This control panel then handles the preheating on the lower plate in this part of the printer. The strength of the vacuum suction, which is under the print head carriage or under the foil here in the printing part, is something that you can regulate through the printer menu. Now let's look at the oil separator. After each main switch on of the printer using the central on/off switch, the extraction should also be turned on at the same time. The suction works in such a way that from the upper space where a lot of water vapor and a lot of oil are released when the foil is baked, it simply pulls it down through the middle and sucks it in through the tube. And then inside there are a large number of thin tubes in which the steam cools and the oil liquefies and then flows down into the lower tank. Then on the other side there are 2 tubes, thanks to which the oil can then be poured out of the separator normally. Then we have a fan at the back, which serves to create a fairly strong draft of air from these aluminum elements, and it cools the aluminum elements. So we will always only get lukewarm or warm air from this side. And then from this outlet here, and that pipe is about 60 millimeters in diameter. From this outlet here, depending on the settings, which we set with the control knob on the other side of the separator, we will get a large amount of warm air, or it could simply be smoke. This means that at each operation it is necessary to ensure that a hose or pipe with a diameter of approximately 60 millimeters is connected to this part, to the outlet part, and that it is either led out of the room, or it should be connected to air, which may simply be ready there for operational reasons in each room. Let's take a look at the sharp print. In this case, the printer initially left about 40 centimeters without the actual print and just the foil. And this is necessary so that we still have enough space for the powdering and for the propellers to knock off the excess powder. Furthermore, the moment the foil drops down, the proximity sensor will be activated and the sensor will send it into the oven for the first time. We see that now, about 20 centimeters. Then the printing continues. We pull it over the other rolls and around the fan at the back until it actually comes out completely. And then we grab it onto the winding system. And then the end of the print will be that we leave about 40 to 50 centimeters of free foil there again. And either we grab it with the train suction by turning on the suction, or we put a weight there and wait about 4 to 5 minutes until the foil is baked in the baking pan. Let it cool and we're done.
First, move the carriage slightly outwards. Open the inspection door inside. You'll find 2 wiper blades and 2 capping tops. Dip a swab in water and carefully clean the wiper blades and capping tops. Next, use a lint-free cloth to wipe away any waste ink around the capping station. Unscrew the waste ink bottle and dispose of the waste ink accordingly. There are 4 threaded rods on the capping station. Ensure the rods are clean and free from dust. Apply a small amount of lubricant evenly along the threaded rods. Test the capping station to ensure smooth movement. Reapply the lubricant regularly can help the smooth operation of rods. For smooth and high-quality printing, we need to clean the encoder strip and guide rail weekly. You need to prepare a cloth, alcohol, and a grease. Wipe off the dirt and dust on the encoder strip with a lint-free cloth dipped in alcohol. Wipe away any dust or dirt using a lint-free cloth. Or apply a small amount of grease to the guide rails. Performing a print head test before starting daily printing is crucial. Upon turning on the printer, the initial step is to conduct the print head test. Ensure the print strips are complete. If not, proceed to clean the print head. After completing the cleaning process, perform the test again. Once your test strips match those shown in the video, you're ready to commence printing.
Let's look at the next print now. This is something that we have implemented ourselves at the company, also as a demonstration of how beautifully the printer can print in color. And what everyone is interested in is simply how to make interesting, high quality, contrasting prints on black t-shirts. This means graphics that are folded or divided into halftones, and the black background color is simply removed from the graphics. Our oven is currently running at about 166 degrees. And as for the preheating of all 3 settings, there were values of 40, 35, and 40 degrees. It's baking beautifully here. In this automatic mode, the printer sends the prints that are already baked further and further. As for the RIP software, we'll talk about that in the last part of this video. So for the purposes of halftone printing, you need to make a correction for the black color there. Let's move on to transfers now. Here we press onto technical polyester, which means that the transfer is very fast. We press at 135 degrees in about 3 to 5 seconds, and you see actually immediate removal. That is, the mode is hot peel. The Otter Pro films we print on are automatically both hot and cold peel. It is possible to use them in both modes, and let's say that the appropriate mode depends on how large or small the print is, and then how big or small the elements are within that print. That means the print, as we see, is not on the video, it's large, and the individual parts of the graphics are merged into each other. That means it holds everything together for us. And in this case, it's actually easy to take it off once and for all. And the more we go into, let's say, the smaller elements, the more you have to play with the temperature and time to achieve good results. Let's now look at a printer where maintenance is a bit neglected. Or let's say, some major cleaning. Here, for some kind of demonstration, let's say, or whatever we have floating around in quotes, we flooded both the CMYK station and the white one. We usually flood the white one and leave it completely filled to the brim with normal tap water overnight. Or if you don't believe it, you could try distilled water. In any case, the station inside should be thoroughly cleaned. Well, if it wasn't filmed with a camera, it wouldn't be visible, or if we just lightly observed the white head, one wouldn't really be aware that the CMYK head wasn't properly wiped. That means two things needed to be done here. First, wipe it all off again and get the hardened ink out. And that's what we're actually doing right now. That means, the general advice is, or is it like a common part of the maintenance kit? That one has some kind of fabric that doesn't shed hair. Here we are replacing it in this case, and more or less most companies do it this way. They buy regular paper napkins and soak the napkins. To completely dry run it is stupid. You can see that there is an awful lot of dust or residue left there. And also, even if you soak it, it actually improves it a little, but it's just not great. This means here, even though theoretically it's enough to have the trowel cleaned, say 2 millimeters or 3 millimeters from the top, you can still see here that there is actually an enormous buildup below. This one was created after about 3 or 2 months. So it's just, let's say roughly maintained, so that the trowel is clean on top. And you wipe it several times a day, because you just want those 2 to 3 millimeters from the top to be really clean. But you can see that here we have a fairly dense and solidified layer of white and CMYK ink. Now let's move on to the calibration. That means, the idea here was to raise the level of the squeegee a little bit, a millimeter, so that it would wipe better under greater, let's say, pressure of the CMYK head, that is, H1. Well, this is done through the menu, in the station settings. Here is the station setup, and then we click on the positions that you see in the video, and then we return to the menu twice. We confirm height once, which is the height, and confirm POS a second time, which is the position, and then, when you start either the cleaning, or you can start just the wipe nozzle. That is, through maintenance we give the command to just wipe the squeegees. That means that the cleaning process doesn't actually run, but it just does the wiping directly. So it actually wipes it, and then you can see if you have achieved that success and if the head is already wiped as it should be. Here, a colleague from Best Sub shows how to clean the print head from the bottom. This means that at the moment when there is so much printing that a fine deposit is formed on the edge of the lower thick sheet metal, which is roughly a millimeter. and then the two grooves in which the print nozzles themselves are located. The head is cleaned or wiped with a stick with cleaning liquid, the one we currently have in red. And then standard cleaning is performed. Let's look at printing again, this time from a software perspective. If you spend 10, 20, 30 minutes with Otter RIP, everything will become more or less clear. However, some further fine-tuning will definitely be needed in the future. The standard assumption is that the best format for, say, input control is the PNG format. This means that it is an sRGB color space in an RGBA format, which is standard RGB plus an alpha channel. Later we will show you what the images look like in XNView. However, it is clear here where there is or is not transparency. If you insert the graphics into the RIP, you can insert them as separate files. Select them individually with Shift or Control, or take them as an entire block. Well, here is the current video Otter S40, which means we have 42 centimeters of foil. Even with the side stripe, we are able to print the 40 centimeters with the CMYK control stripe. Which means we set the work area to 40 centimeters, and then the graphics can be more or less down to the last pixel. From a textile perspective, if you put an A4 on your chest, the width is 210 millimeters when standing upright, and about 297 millimeters when wide. This means that the 40 is capable of handling more or less any large print on any t-shirt up to, say, XXXL size. So the 40 doesn't actually limit us in any way. So here you see that we have uploaded some graphics, so that by grabbing it into the block, you can immediately see how wide the graphic is. Of course, I can prepare the PNG format 1:1 at 300 dpi, and then the import would be completely clear. The sizes would not change. In this case, we adjusted it a bit and started RIP/printing. We chose two modes there. One was 1200 dpi, the other was 1800 dpi. We printed in that in here. For the sake of interest, we were asked how it is ripped, how much time it takes, and what is the processor usage. In this case, we had an 8th generation processor. I think the 14th generation is currently being sold. So we have 8-year-old hardware here. It runs quite quickly, and a person is able to RIP about 5 meters of graphics in 5 to 5 minutes. So there is actually no slowdown in the workflow here. Here we insert the graphic on the right side again. Then we add channels W1 and W2, thus defining white for that white. We should then define white. We should then define how much the choke parameter in Navigate will be. That is, how much we encapsulate the white color under the individual CMYK pixels. We also have black balancing here. That means if a person were to start with halftones from the beginning, then you need to learn to work with it and set the threshold, i.e., the sensitivity threshold for black, so that the output is correct. Here, if we look through XNView, then through the M key, mask, that is what we get. That means PNG is, let's say, the simplest and fastest format to check, and especially in the graphic on the left side. We can already have pixels that have a certain transparency. This means that if you are already working with halftones or AI-generated graphics, transparency would and will always be a problem in DTF, but that's something you can easily check with XNView. Then the last thing we have here is, if a person were to print directly from the control software, that means not from the RIP, but directly from the control software, only PRN files that they had ripped in advance or historically. For example, a week, months ago. So here it shows us how much printing performance we get in the case of 1200, 1800 and 2400 dpi, and it's roughly 8, 5, 2 and 4 regular meters per hour.